I don't know if you remember, by the way, Landon, when it's that A and that B, that's just that column. It's just X and Y. You can erase the A. Okay. Yesterday, I worked through, I just remembered something. Miles, you aren't doing anything right now. Can you pass these out? Yesterday, I worked through quite a few of the problems on the check your understanding. From the forms of quadratics, I can do that with some of the others as well. So you had the solutions all along, but I've worked through some of them, showing how I got those values and posted that video on YouTube. So if you are still struggling with some of the check your understanding things, please be aware that that resource is online as well, and hopefully that will help. Last thing before we get going today, I do want to point this out. We're going to do a demonstrated understanding analysis and corrections, and we're going to start-ish on the next unit, not really, but it's going to help set us up well for the future. With that in mind, right, so we're reviewing today, and I have an option for you, but like, this is a choice that I'm offering to you as a class. I already have the test ready. However, based on this demonstrated understanding, I think a few of us need a little bit more time to study. I would say about 2/3 of us, I would feel comfortable being ready tomorrow. 1/3 of us, even with today, I think you need a little bit more time to study. So the options are this. We take the test tomorrow, start the next unit on Monday, or we start the next unit tomorrow, which we'll use to also review-ish this current unit, and then test on Monday. Testing on Monday is dicey for some of us, but that gives you 3 more full days to study before the test. So, if you want to take the test tomorrow, please raise your hand. If you would prefer to take that extra time and test on Monday, please raise your hand. Okay. The whole point of this is that you have extra time so that you can come in and crush it, right? So, remember we have all those resources online. I will note on the YouTube videos, I didn't always say if it was first block's video, but if it doesn't say which block it's for, it was for first block. I always labeled it 3rd and 4th, so first block are the videos from this class. First block, I've labeled all of those videos to identify what we studied during that time, focus on what you need. Again, I did check your understanding, video of the check your understanding with the different forms of quadratics, and I apologize, I thought I had given you this check your understanding on writing equations already, and then I realized yesterday I had not, so I printed it out. But that's extra practice. I did put those online as well. Does anyone want me to upload videos working through check your understanding on identifying functions or writing equations of linear and exponential? Which part? Yes, or just one of those?
Can you say both or just one?
Okay. You can say both. Both, okay. I'm not going to do every problem, but I will do some of them, again, just as an extra resource. From there, let's get going on demonstrating understanding analysis. So remember, we got to know our forms. First off, guys, number 1 should have been a gimme. We've got to know those 3 equations. Like, there's no ands, if, buts about it. If you don't know those 3 equations in number 1, it's going to be a really tough time trying to identify those different features. Another thing I would encourage you to do is, I wouldn't just say, hey, factored form, right? So remember, well, first off, remember the name tells you a lot. I saw several people call this vertex form. But what do we mean by factors? Well, the factored form has roots, but like, what does that word factor mean? Multiply, right? This is literally called factored form because we are what? Multiplying those factors, those expressions. That's why it's called factored form. Why, which one is this? Vertex form, because literally h comma k, remember an input of h gives me an output of k, that's my what? Vertex. And every polynomial, it is standard to do something like ax squared plus bx plus c. Later, we're going to study cubics, the standard form of a cubic, the standard form of a quartic. This is why we call them standard forms, because they're always going to follow that format. Okay? That's why we call it a standard form. If I didn't mention that before, that's why. But they have specific meanings to that name. It's not random names. Okay? We good? Does that help clarify a couple details? So that's just number one. But again, remember, we need to be able to identify key features. And again, remember, one thing I should point out is each form has their own key feature. Vertex form has the what? Vertex, but also, most of us forgot, it also has a line of symmetry, doesn't it? Vertex, line of symmetry. So, does vertex form have any other features? And concavity, sorry. What does every form have? Concavity, right? The A has the concavity, right? Someone was asking how to find A. First off, if you write out that equation above it, it tells you A right away, but vertex form has vertex and line of symmetry. So does it have the y-intercept? No. I have several people who told me K was my y-intercept, and that messes you up. K is not a y-intercept. Which of these forms has a y-intercept? Standard, with that C right here. Don't forget, every y-intercept that has and will ever exist has what is true about it. That x is equal to 0, right? My input is a 0. Which is why this becomes 0 plus C, or just C. But if I substitute 0 into here, I'm not going to be left with K. If I substitute H in, I'm going to be left with K. If I substitute 0 in, I'm not going to be left with my R1 or R2 is not going to be my y-intercept. But can I find my y-intercept that way every time? Good with that? So how to graph the equations of the graph correctly, how to convert forms, okay? So we'll look at some of that. How do you convert factored form to standard form to vertex form, and determine the equation in vertex form, and then this one. Okay, so converting this equation into vertex form, that's one of the questions. Now, first things first, we need to recognize what form it is. This person up here is asking how to find A. What form are we looking at? Standard, so what's the form? Right? Unless it's a parentheses x minus, it's always plus. So, if you write out that standard form very clearly, what is A? Notice it's not negative 3x squared. X squared is x squared. A is just negative 3. If you write that form above it, there it is. Is that also evidence for why the parabola is concave down? Yes. Now, I need y'all to be careful, because I saw this a whole lot. What is conceptually wrong about that? There's a major concept that we're misunderstanding here. Okay? Say again. So we got to remember, A is equal to negative 3. A is a number. A number is not concavity. Now, because A is negative, you could draw an arrow maybe, or say the word so, the parabola is concave down. But we got to remember, concavity is referring to the parabola, not a number. The number just tells us the concavity. I need you to keep that in mind. And so if you need to update that on your demonstrated understanding, I already have scans of these. You need to write on a separate sheet of paper. I already have scans of these. But A is negative 3. So the parabola is concave down. Concavity refers to the parabola, not the A. Okay? Comfy with that idea? Now again, this is standard form. Once again, if I want a y-intercept, what do we know about every y-intercept that's ever existed? And will ever exist? The x value is 0, right? Y-intercept, x is 0. And so that's why we can clearly see that C is my y-intercept. Negative 2. Now be careful, again, I had a lot of people say C is the y-intercept, and that's mostly true, but remember, What do we know about every y-intercept that's ever existed? That is my y-intercept. C is equal to -2. So there's a difference between it, right? C is a number, the y-intercept is a point. Mathematically, that does matter. I bring all this up to answer the question of how to graph, right? So as long as you had a y-intercept of 0, -2, and that parabola was concave down, you were good. Except if you did this. That's okay. But what are you also making the y-intercept right there? The vertex. Is that vertex the y-intercept? Not usually. Very rarely is the vertex your y-intercept. I did not dock you too much on that because it's just a small misunderstanding. What it really should have been was either this, or something like this, or something like this. Either one of those would have been acceptable here. Notice you don't have to have it exactly. Like Drake, you were freaking yourself out. You're like, I have to have it a very accurate parabola, right? I just need you to be able to recognize what it could be based on standard form. A y-intercept of 0, -2, concave down. And show me you understand that. Make sense? If you go in and you look at the check your understanding questions, that's all I did for all those standard forms on the medium section. Now, if you want a CCC plus, you add in those extra details. If you want to hit the exceeds portion of the proficiency scale, you hit those extra details. Now, because we're asking for the conversion, I'm going to go ahead and talk about it here. First off, if we want vertex form, what do we need? Well, what is vertex form? What is it?
A times x minus h squared plus k.
Please notice, because I saw a couple people doing this, are h and k the same as b and c? There's a reason why we use different letters. Okay? We got to remember that we use different letters for a different reason. And this portion right here is part of that exceeds. Do you need to hit the exceeds on the proficiency scales? No. Now, if you go ahead and learn this about the vertex, it's going to help next unit a whole lot. So I would go ahead and pay attention to this. How do I calculate h from my standard form?
Minus -2a.
The opposite of b divided by 2a. Remember, guys, if you typed in that Desmos code, you can actually go back into those Desmos activities. You just log into Desmos, and it'll be right there in your dashboard. And you can go back and see this, but we played around with it, and we saw that h was -b divided by 2a. Or opposite of b. So what is b in this problem? 6, so what's the opposite of 6? Divided by 2 times what is a? -3. And so -6 divided by -6 gives me an h of 1. I tried to make sure these numbers were nice and easy because I know I didn't let y'all have a calculator, but we go with -6 divided by -6. Okay? Now, does anyone remember how I can easily find that k? Because it's not -2, it's not the c. What is k? Let me point this out. What's another term for the h right here? It is an x value. What's another term for the x value?
Input x.
So be careful, an x-intercept is only on the x-axis, right? And the y value would be 0, but what did you say with that, Elizabeth?
Input.
Isn't the x the input? So if I substitute h in, what should I get out? That's how I find my vertex. If I want that vertex form, I want my vertex, then I substitute that one in. I substitute h in. And I just go back to the original equation, right? Substitute one in. Xander, I believe you got this. What was the output here? 1. Yeah, I was trying to give you nice easy numbers. -3 plus 6 is 3. 3 minus 2 is 1. If it's a non-calculated portion of the test, by the way, and you want to make sure you substitute that 1 in, you got that calculation right, I'll tell you if you got that calculation right. I'll do that calculation for you because I want to see that you understand how to get the vertex. And if you have a calculator, I know you can do that. So, come back to here. A lot of us made our life really hard, right, Elizabeth? Crushed it up to this point. But what did you try to do at this point? Did you do a whole lot of extra work to find A?
Yeah.
Yeah? Hey guys, what's A? We had A from the very beginning here. When you start off with one form, you don't have to find A again. That A was -3 and it will always be -3. That's why we use the same letter. Right? We have to find A when you're given a graph, when you're given a table. So please note that to yourself, right? We only have to find A if we don't have it, but we have A from the beginning. It was -3. Okay. Now again, do you have to get to vertex form for the target portion of this unit? No. But I'm going to show you later today why you might want to know how to get to vertex form before next unit. The sooner you learn this, the better. What are your questions up to this point? Shadija, are you with me? Can you stand up, move around a little bit, get that blood flowing so you don't fall asleep? You good? Okay. Davian, you good? Trying to fall asleep on me too? No? Guys, if you need to move around, go for it. I'm okay with that. This classroom is designed to be flexible so that you do what you need to do to be successful. But at this point, notice we have everything just about for this graph. Remember I said you can do this y-intercept, right? You can do any of that, any parabola that goes through that y-intercept, except making that the vertex. But by now, we have a more accurate graph, right? So Drake, you want that more accurate graph, that vertex gives it to me, right? What's my vertex? Just in general. 1, 1, right? H, K. Now, also remember what goes through our vertex? That line of symmetry. This is one thing I saw Xander do that I thought was fantastic, and I would encourage you to remember. If you know that line of symmetry, don't you know the point on the other side as well? So that's a more accurate graph. Notice concave down. Use that y-intercept to get the next point as well. Did you have to have that level of accuracy? That's that exceeds portion. Okay? But that will be helpful to you next unit in getting going. What questions do you have about this problem? About these features of that quadratic? Yes, ma'am.
Whenever you're substituting H in, do you have to do the original one, or can you do it like into the vertex form?
So if you do it into the vertex form, you don't have A. So how are you gonna?
Like, can we like take A like from the top one?
Oh, I see what you're saying. But then in that case, you don't have the K. So like it would still be K here.
I'm saying like when we're trying to find K.
Right. So
Like once you've already found H.
I'm gonna go ahead and say no. I'm trying to think about how to explain why not. So let's say we have H equals 1, right? Then what you have at this point is just, you have -3 times x minus 1. I mean, yes, as long as you use another point, I guess, you can. But in this case, you would, to find that k, you would have to use another point other than the vertex, because you don't have k. Like, you don't have an output. Now, if you wanted to say f of 0 equals -2, and so your output is -2, right, using the y-intercept, equals negative 3 times x, no, x would be 0. Notice that does have one variable, but if you just use the standard form, you just substitute it in and your output is k. So yes, you can. I would never, personally. Hopefully that answers your question. So, yes, you can. It's just significantly more complicated. Remember, h is my input, k is my output. That's all I'm going to do, and I'm going to go back to that original equation. So I will make a note at this point. Several of you should be asking a question about this graph. Quite a few of you have the ends of your graph circled with p's there. Do we not have a question about that? You have a graph like this, and several of us do. Or maybe it's like this, on one of those ends. What's the problem with this? What's the issue? Say it louder. Okay, so one, not symmetrical, but let's say it even was symmetrical, right? Let's say it was symmetrical. This is still not okay. And there's one critical reason we need to know it's not. Okay, so there definitely needs to be a y-intercept, but I'm ignoring that. I'm just talking about there's major problems right here.
Does it go all the way down?
It's got the arrows, that's okay. It's straight. Is this a function, guys? Like, this can't be a parabola because that means this one input has infinitely many outputs. If you look at any parabola I've created, if you look at the parabolas on the graphs I've given you, if you look at the parabolas on the backside of this demonstrated understanding, doesn't it always go out and up or out and down? We need to recognize that that's not a function. I'm not asking for the most accurate graphs in the world, but I am asking that we do not go straight down like that, because that's not a function. Okay? So if you did that, please update that note, right? This is not a function. This is not a parabola. It's got to go a little out at all times. It can be super steep, right? But notice how it's still going a little bit out. It's not a perfectly accurate graph, that's fine. But it cannot be straight down. It cannot curve back inside, because if it curves back inside, it's not a function. Does that make sense? We go with that detail. Questions on this one? Going once, going twice. Sold. Okay. We didn't ask too much on the vertex form. The only note I will make on this one is, please remember, can you write the equation above it to help you earn credit for understanding which form it is and naming it? Can that be helpful? 100%. If you also write these things and you understand what those letters mean, right? So Jaden, were you the one asking about how to find A? See how A is literally right above the 1/2? So A is 1/2.
Well, I just really want, what if it says A and not the numbers?
Wait, there's no number in front?
It says A.
Are you talking about when writing an equation? Got it. We'll get there. That's my bad. Alright. But again, just write it above. Also remember, when it's x minus, what do you always need? Starts with an O. The opposite, right? Remember, the idea is that we need zeros in here. So h needs to be, well, yeah, h is a positive 3. Because if I substitute that 3 in, what's 3 minus 3? 0. Right? The whole idea is I need the opposite to be able to get those zeros. That's what's true for for the roots and for h. So this vertex should have been 3, -2. And then be careful with graphing it. I had a lot of people graph the point -2, 3. I had a lot of people graph -3, -2. Remember, guys, x is horizontal, y is vertical. So any questions before I move on? Okay. Now, can I go to standard form from here? Can I go to standard form from this one? Yes. Did I ask you to though? No. You can. We're going to talk about how you can do that with number 3. Oh, the one last thing I will point out about this is, could I find my y-intercept? Is there a way to find the y-intercept from this equation? Definitely. Definitely. Xander did it one way where you found the standard form of this equation, didn't you? Say again? For this vertex form? I thought you went to the standard form to find the y-intercept. Well, you used the... Okay. Yes, but you went to standard form. So, what Xander's referring to is he rewrote this x minus 3 squared as x minus 3 times x minus 3, but didn't you then multiply or distribute?
Okay.
Right? That's what gets us to that standard form. And so that wouldn't be factored form. It's not a times x minus r1 times x minus r2. You just wrote it out and multiplied it to get to that standard form. That's what he did. Because what is the y-intercept in standard form? It's our value of c. But why is the value of c my y-intercept? Guys, what do you know about every y-intercept that has and will ever exist? That x value is? That's how I find my y-intercept. If you want that extra level of information, the y-intercept, x, is always what? 0. Just be careful with how you're simplifying this. I'm showing every step right now. You don't have to. Remember, you can just type this into, well, I guess you can type it into a calculator. Sorry, that's a lie. You can, though. So 9 halves minus 2. If you need help with those calculations, just let me know. I need a common denominator. And so the y-intercept here was actually 5 halves. But don't graph the y-intercept unless you actually found it. Don't graph the vertex unless you actually know the vertex. So, and by what I mean by that is don't put an actual point there. Okay? So, y-intercept is something you can always find because the x is what? 0. Y-intercept, the x is 0. The similar thing is true with x-intercept, but the x-intercept's a little bit more of a pain in the butt to get to. That's what next unit's all about. Alright. Once again, write your equation above it. It helps. It really does. We recognize factored form, we write out factored form. It helps. Helps me identify my roots. Converting to, so remember it's 3, 0, negative 1, 0 because I need to create those zeros. It's concave up so I can sketch it a little bit there. But let's talk about the vertex because people are asking about how to convert it to vertex. Now, do you have to convert into vertex for the target portion of this proficiency scale? I think if you look at the last detail, the only thing it says is I can convert from factored form to standard form. So do you have to go from a factored form to a vertex form? Nope. That's part of that exceeds. In standard form, h was equal to the opposite of b divided by 2a. So once you get standard form, you could do that, but does anyone remember what I can do with my roots to find what h is? I can average them. Like, I'll point this out. If y'all just look at this graph, why do I know my line of symmetry is right there? It's in the middle, right? Isn't the line of symmetry in the middle? So what is h? What is h? 1. That's the line x equals 1. That's the line of symmetry. My h is 1. That's it. And I find that by averaging my roots. My first root's 3, plus my second root is negative 1. To average, I divide by how many numbers I added together. What's 2 divided by 2? 1. Notice how that matches up with what we see on the graph. So that's an extra detail that can help. And the next detail is the same from standard form. If h is my input, what's my output?
Okay.
K, right? So if I substitute h in, I get out k. So g of 1 is equal to 2 times 1 minus 3 times 1 plus 1, or 2 times negative 2 times 2, or negative 8. My vertex is 1, negative 8. I think Xander, you went all the way to the standard form and then went back to the vertex form. Can totally work. But I think that's a little bit simpler to do it this way. Notice, you can do it multiple ways. There's just a simpler way in this case. Now once again, did you need to get that vertex form? Or did you need that vertex? No, but it could be helpful. This is negative 7, negative 8 is roughly here. It's going to help me have a more accurate graph. By the way, that would mean g of x. By the way, you didn't have to, but does anyone know how we could have found the y-intercept to have an even more accurate graph? Miles, let me ask you this. What do you know about every y-intercept that has and will ever exist? So what could I have done if the x is 0 to find my y-intercept? Can I substitute 0 in? That hasn't changed. I will point this out. Each form has their own way, or has their own unique feature that's easy to see, but can I always find the y-intercept? Can I always find the vertex and the line of symmetry? Those are not the things that you have to identify each time, but those are things that are discoverable. What's the only feature that's hard to find, or I haven't said you always need to find or can find? The x-intercepts, that's what we're going to get into though, to make more accurate graphs, right? At the end of that drink, that's when I'm really going to want those more accurate graphs, once we get more practice with it. But, if you substitute 0 in, you're going to get a negative 6 out. Is that right? Yep, negative 6. And just like Xander did, you can use that line of symmetry to go to the other side. With that earlier problem, he did that. That's honestly about as accurate as you can get with this graph. Notice once again though, it's going out and up. I didn't justify all of it, but I do want you to notice, like, that's how I get it, right? Not just writing down answers, but explaining some of those things. So I'm going to let y'all update your notes a little bit. Okay? So, last detail. We did a good bit of this over the last couple days. A little bit of practice, guys. If I want to go from a factored form to a standard form, what do I need to do? So the box is a tool to help me what? Distribute, right? That area model is what it's called, to help me distribute. Now, like, you can distribute without it. It's your choice, but I'm telling you, and I promise you, having taught this long enough, this area model is really going to help you when you get into more complicated things. A general principle that I always try to operate under is I'm going to do something that always works instead of trying to teach you something different every time. So if you go ahead and start learning that area model, it's going to help you in distributing. X minus 3, x plus 1. One thing I will note, actually let's write it this way. To make my life easy and to make sure I don't make mistakes, whenever there's a negative, I just put the minus there. It helps me know what's negative and what's positive. That's just me. X times x, x times 1, negative 3 times x. Now I'm going to pause for a second because negative 3 times 1 is not negative 2. We got to be careful with this detail. What's negative 3 times 1? Negative 3. Several of us made that mistake. Be careful and just pay attention and learn from it. Negative 3 times 1. That's why I put the little multiplication symbol up here. And so, we're adding all these terms. These two are like terms. So what do I get? I'm done, right? Nope. Forgot my 2. I actually forgot something else. Anyone know what else I forgot? Guys, if you don't have that it's equal to an output, you don't have a function. I saw several of us that had expressions, but didn't have an output there. Make sure you put equals g of x, equals f of x. But then yes, I distribute from there. Questions going once. Questions going twice. You okay? You trying to sleep on me back there? Oh, she's out cold. Davis, help her out. If you need to turn the desk so it's harder to fall asleep, go for it. Take some notes, update your understanding. Alright, questions about converting to standard form, how to find that vertex, all the fun stuff. Actually, instead of changing the slide, I'm just going to work on what Landon put up here. Hey, does anyone know what this orange parabola I just drew is? It's what? I can't hear you, Miles. Oh, I already had it in there. Nobody? No guesses? One, 0. 2, negative 2. 3, 0. 4, 6. I decided not to go with the 5, 16 because you. But notice I used the idea of a line of symmetry to get my y-intercept in there. Do you have to keep a table as a table? Do you have to keep a graph as a graph? Use whatever's most comfortable for you. I do want to point out that this tells the same story because those two representations are what? Equivalent, right? Same inputs mapping to the same outputs. You use whatever's easiest for you, but that's why I started the whole unit with those tasks. And I know it's been forever, but the bottle and the cork, we looked at Roy and Joel going to the pool, right? You create the representation that's easiest for you. Same inputs mapping to the same outputs. And now it's very clear, one, is this quadratic? Yes. So I need to use a quadratic equation, don't I? 2, I just want to point this out. I had a lot of people doing this. I don't know about a lot, but I had 4 or 5, which is too many. 0 plus 6, is that 6? But is 0 plus 6 negative 2? We need to be careful. Pay attention to that. Update our knowledge. But like, pay attention to what's actually happening. Because if you have constant additive here, what type of equation should you be trying to use? A linear equation. This is not a line. Make sure you pay attention to that. But notice you can also check the rate of change. What does this plus 4 reveal about this orange section right here? Linear, additive, rate of change. This purple is constant additive, so the orange has to be linear. We're adding, and it's the rate of change. Which again confirms we have what type of function? Quadratic. It's all telling the same story, just from different perspectives. Now, Jaden was asking about finding the a. That is a very valid question, right? Now, do I need to use standard form, factored form, or vertex form? I need to use factored? It doesn't matter, I can use any of the three? So, I can use vertex, I can use factored. Technically I can use standard, but have I taught you how to do standard? No, it's a pain to start in standard form. If you got a vertex though, what can you start with? Vertex form. If you have roots, what can you start with? Factors, right? Or factored form. I don't care which one it is. I'm going to do one of them with you and I'll show you the work for the other really quickly. Raise your hand if you want me to start with vertex form. I got it. 3. Raise your hand if you want me to start with factored form. Okay, I'll show the work for vertex form, but I'm going to start with factored form. Right away, I will point out, how do I know that these are my roots?
Y is 0.
The y is 0, right? Remember, roots are x-intercepts, or connect to the x-intercepts. So we'll say we're going to learn how to find roots that are not x-intercepts later. There's always 2 roots, but not always 2 x-intercepts. It's a whole thing. We'll talk about it. But if we're starting with factored form, most of us did not follow this very simple recommendation. Once I identify I want factored form, guys, write it out. Just write out the factored form. Every time you write that equation out, it's going to help you remember it. I know people are like, I struggle to remember things. Well, do the simple things to help you remember. Flashcards, where you have the name of the form on one side, you have the equation on the other side, and you have a friend quiz you and pay attention to those details. Where you have the equation on one side and you're looking at the equation and you name it. Write it out every time. All of these things will help you remember. Practice, 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 practice. It helps. And then what do I already know from this equation? Do I know A? So I'm going to leave it as A. Do I know R1? So remember, it's already a positive, so it's just going to be x minus 1, right? I need the opposite within the thing. So if it's a positive 1 here, it stays minus 1. And then x minus 3. We good? Okay, I need A now. So I don't have it with this table or with this graph, but I have a whole bunch of points, right? And those points are also called inputs and, does it matter which point I use? No. I will say because I have factored form, I actually can't use my roots, but I can use any other point. Doesn't matter. Which part of this equation is my output? F of x. And I need y'all to be careful. So everybody, eyes and ears here, I need y'all to pay attention to this. I had a lot of students tell me f of negative 2 equals in one part of it, and then they wrote negative 2. But in this case, what are we saying negative 2 is? Isn't that in the place of x my input? So f of negative 2 is not negative 2. F of 2 is negative 2. That's why in the x over here, I would substitute what in for x? 2, right? Same thing here. F of 6 is not 6. F of what is 6? 4. Which is why 4 will go in for x, 6 will go in for f of x. So it doesn't matter which point we choose. I'm going to go with 6, or 4, 6. So notice I just put 6 in the place of f of x. The f of x is my output, 6, equals a times, what's my input?
4.
And now I have an equation with how many unknowns? 1. One unknown. Simplify, then solve. So Jaden, once you substitute your inputs in and output out, or put your input in there and substitute your output for f of x, you simplify and solve. That's it. What's 4 minus 1? 4 minus 3. And so I am left with 3a. I've simplified as far as I can go. Hopefully you recognize 3 times what gives me 6? 3 times 2, right? A is 2. But also, what's happening between the 3 and the a? They're being multiplied. What's the inverse of multiplication? Division, right? I multiply by that 1/3, that reciprocal. 3 divided by 3 is 1. So a, again, is 2. Now that's what a is. Make sure you go back and you substitute that again. That's my final equation. Okay, while some of you are updating your notes, I'm going to do that vertex form. Again, I start with vertex. I don't know A, I know H is 2, K is -2. I'll use the 516 to show it doesn't matter which point. My output is 16, my input is 5. Simplify as far as I can go. Once again, what does A come out to be? 2. And so this would just be my vertex form. Telling the same story from different perspectives. It does not matter which point you use as your input and output. You just gotta solve. I will make a note here. What seems easier to solve, the factored form or the vertex form? The factored has way less work, way less steps. If I have the opportunity, I'm going to go factored form over vertex form every time. But it doesn't change. You simplify and you solve. You with that, Kyron? Okay. Now, at this point, we need to study, to practice, and I want to support you in whatever ways we want to do that. So what I'm going to do is I'm going to leave it up to you to self-identify what you want to work on. First off, is there anyone who wants to work on identifying linear, exponential, or quadratic functions from any representation? I figure that's where we're most comfortable. Is that fair? Okay. By the way, y'all can move flexibly among groups. Is there anyone who wants to work right now, at least to start out, on writing linear and exponential equations? So that means we're all comfortable with, so we feel like we're on the target for both of those proficiency scales all the way across the board? Okay. If you decide to change your mind and you want to switch to a group for that or work on your own, we can do that. That means we're all looking at either graphing those quadratics or writing an equation of a quadratic. Is there anyone, so let's do this. Standard, so graph and features from standard form, from factored form, vertex form, okay, and then converting among forms, and finally writing equations. Again, we will work as a group, but you can move, we'll be flexible. Those are the 5 ideas under quadratics that we're mostly going to focus on. Is there who wants to focus on identifying the graph and features from standard form? Starting there. Okay. Bella, my bad. Bella wants to do that. Anybody else want to join Bella on standard form? Coach got that. All right. So let's do this. Bella and Hope, you'll go to the group of 2s when we move in a second. Anybody who wants to work on factored form? Davian, Shadidra, are you raising your hand? Yes? I mean, you don't have to. I thought you were raising your hand, no? Okay. No one else wants to join Davian? How about this, Davian? Why don't you work with Bella and Hope, and we'll work together on that, and we'll actually move to the group of 9 so that you have a group of 3, okay? Vertex form. Who wants to work on identifying the features and graph for a vertex form? Okay? That's what you want to work on as well, Shadidra? Alright, so Davis, Shadidra, Leah, y'all gonna be the group of 8s. Sound good? Converting among the forms. Got it. Okay. Let's do this. Taylor Elizabeth, not Elizabeth, Mary, Mary Elizabeth will stay in the Kings then. Who else wanted converting among the forms? All right, so we've got that. 1, 2, 3, 4, 5, 6, 7. Okay. Davis, Brianna, Jaden, y'all gonna go to the group of 4s. Was it Miles, Sarah, and Danita, you as well? Okay. We'll go with Jax for y'all. Sound good? Who's writing equations? Who's writing equations then? Kelly? Who hasn't chosen a group yet? Did I not put you in a group? I thought I put you in the 4s with converting. Didn't you have your hands up for that? Yeah, you're in the 4s. If I didn't say Landon, I meant to say Landon. Okay.
Can I work on graphing factor?
Graphing factor? Who was in factor? Oh, Davian wanted that, so work with Davian, okay? And we'll have you in the group of 10s. All right, so let's get up, let's move to those groups. If you don't have a group yet, meet me in the center and we'll figure out where you're gonna go from there. By the way, get out your check your understanding questions. That's a good place to start in practicing these things. I can make new problems if necessary.